Okay, this short video is explaining this PowerPoint 2.1 nonlinear graphing relationships. So let's just activate it and make some sense out of it. So this is a linear graph. Linear basically means A is proportional to B. So if you had B here, you doubled it, the value of A would have doubled as well. Okay, and the relationship there is A equals K, K being the gradient or constant. Now the assumption here, by the way, is it goes to the origin, so there's no y-intercept. So you may have come across in year 10, year 11 mathematics, y equals mx plus c. Y-axis could be A, x-axis could be B, the gradient here could be K, and the y-intercept is 0. So what happens if your graph is not linear? And here's an example here. It says A is proportional to B squared. So that's a squared relationship. And what you have to do here is you have to take your data and linearize or change the B value. And if you made it B squared, if you plot B squared on your x-axis versus y-axis A, you'll get magically a linear line. And that's useful because you may be able to work out the gradient from this. You will be able to, and that gradient could tell you some information in regards to your 2.1 or 3.1 investigation. So the key thing here is the mathematical relationship is now A equals the gradient here times B squared. And so what's happened, you had non-linear data, and by changing the axis, it's now linear data. And that is the whole point. The next module, by the way, 1.5, I think it is, will talk about how you deduce information from this graph here, this line. Okay, this relationship here is called inversely proportional. So as f gets really big, e drops down, or as f gets really small, e gets very big. And the relationship here is this one here. To linearize it, you could plot 1 versus e versus f, and it would give you a straight line. Or you could plot e versus 1. Oh, a bit hard to see there. So that should say 1 over f down the bottom. Let's just correct that. Down you hop. Okay. So these are skills. How do you plot this? You need to make up a data table, and we usually call that data table the process data table. And in there you've got 1 over f or 1 over e, and then you'll be able to select those columns in New Zealand Grapher, do a scatter plot, and kaboom, out pops a good result here. Okay, this one here is probably very common in terms of assessments. It's a square root relationship. And the deal here is there's two options, okay? One option is if you were to plot, if you square root D versus C, you'll get a linear line. And that is the objective there. Or vice versa, you could do some algebra and square both sides. And that means the square root disappears. A bit hard to see here. Move you out of the way. Okay, and down the bottom here, you've got, I'm not sure if you can see it, but D versus C squared. That also gives you a linear line. Okay, so just to recap here, this is a squared relationship. You may be more familiar with this maths notation. Inverse relationship, another name for that is called a hyperbola. You may do that in calculus and conic sections. If that's in an internal, you'll do. And here's the square root relationship. Okay, so here's a couple of examples. I'm just going to go through them with you. Power, if you didn't realize it, electrical power is current squared times resistance. The units of this is watts. Okay, so let's pretend you've got this data here, and your challenge is, in fact, in your notes, you are having to reproduce the slides in 10 and 15. So in fact, I'm asking you to see if you can produce this graph here. Don't just copy it and paste it in. That's cheating. Okay, but here's what you're going to do. So you're going to take some data. I'm just going to plonk it in this spreadsheet here. No, I'm not. I'm going to put it into this one. Let's just create up a new sheet. Okay, there's the data. Once in a spreadsheet, then I can copy it and then go to a very useful program, New Zealand Grapher, import, okay, and go to scatter. X-axis is going to be current, power on the y-axis, and okay, I get a non-linear, in fact, that looks like a squared relationship. If you scroll down here, you can sort of see, which one is it? That one there, quadratic. And there's that squared relationship on display there. Okay, but we want to linearize that. Okay, so go back to your spreadsheet and okay, so there we go. We just created that graph there. And what's happened here is because of the squared nature, if we were to take not just current, but current squared, okay, so we need to basically produce this. Let's go to the graph, show you how to do that. Select left column and copy that across. Put 2, oops, didn't work. Got some spacing issues here. Okay, that's looking a bit neater. Okay, so we're saying current squared, and don't forget, always, if you square something, don't forget, you always got to show the units, okay? So if you square something, you got to show the unit squared in this case. So it's saying current squared, so that equals that to the power of 2. That's not hard, and it recognizes that and copies it down. And now we're going to plot these two things next to each other. Control copy, go to New Zealand Grapher, insert, and scatter plot. This time put I squared versus power, and you're looking at a linear line. Regression line, which is linear, and look at that, pretty good. Slightly off, but nothing to be, in fact, there's still a very good regression value. That's amazing. And this is the key thing here. What you're going to work out later on is how can we use this this expression. This is y equals mx plus c, right? Y-axis is power, equals gradient. The gradient of this is basically 100. The x-axis in this case is I squared, and there is a slight non-zero intercept. Now you could argue 27 is nothing in terms of the scale here, so you could argue that's 0. Well done. So that there will be pasted in here. That's slide 10. Going back to the next example, so that's the challenge. Can you produce that example? Okay. The next few slides, let's activate. Oops, just lost my mouse. There it is. Okay, so this is a inverse relationship, and here's a classic example from chemistry. This is called the gas law. Pressure times volume of a gas in a concealed container is equal to nRT. N, number of moles of gas, R, gas constant, and T is interesting. That is temperature in Kelvin, not Celsius, but Kelvin. So that's a fixed value if your temperature is constant. That's called isothermic. And basically what it says is if your volume is very large, the pressure is very small. If you were to do the opposite, compress, make it very small, as you would expect, the pressure would increase. And it's an inverse relationship there. Quite a few inverse relationships to come in mechanics and electricity. Okay, so what we're going to do is we need to just confirm that. Again, just copy the data, go to a spreadsheet here. If you copy that, control copy into NZ Grapher, go to data, input from clipboard, scatter, volume on the bottom, pressure in pascals, and it's not a linear graph. So I'm going to take that one off. And the best one I imagine would be that one. Yeah, okay. And that is the relationship shown by that's non-linear graph, obviously. Now the challenge is, can we, as in up here, can we do one of these two? let's go for this one here. Let's focus on the independent variable on the x-axis here. Can we transform that? Now, basically, we're going to make it 1 over. So we need to go back to our data here, and that's what we just produced. Can we, 1 over volume. So let's go back to this and right-click, insert column to the left, and put 1 divided by this thing. Okay, and that, if you're thinking about it, that's going to be -3 in there. Okay, because it's the volume's on the bottom, so on the top. Yeah. Okay, that's just a bit complicated. Let's make that a bit wider. Okay, so equals 1 divide, slashes divide on the keyboard here, that cell, and it does look awful, but then we can go here and select all the cells and make them basically 2 significant figures. I think looks good. Right, let's just copy that, control copy into New Zealand Grapher. By the way, you can do the spreadsheeting work inside New Zealand Grapher. To me, I think it's easier to work in a spreadsheet environment. It's more, not as chunky. Okay, so scatter graph, 1 over V, P, and wow, that is exceptionally linear graph now. And as we'll learn in the next topic, what's the significance of the gradient here? In this case, 3.0. How can we use that to work out some sort of inner meaning behind your investigation? Righty, that is the end of, and that's your challenge. Can you create that graph here, number 15? I'll obviously put in a good title there as well.